Welcome to this video on teaching long division, or as I call it, factorising polynomials, because I will not be teaching any long division. I find that it doesn't suit my students, and there's actually a way to do any long division question using a technique that they're already super familiar with, which is factorising. So to begin with, a starter suggestion might be to get your students to write down a factorised cubic. So you can be quite loose with this. They can have as many individual roots as they want. They could have double roots, but we're just looking for up to 3 brackets. Then they can sketch it using the knowledge of what the roots are and the shape of the curve, and then they could expand it. And then, so they've got the factorized version and then the fully expanded version, and then get them to reflect on how they could go about refactorizing it. So perhaps they could swap with the person next to them and see if they can factorize this cubic, and if having the sketch would help them, what they would need to know to factorize it. And is it easier to sketch it from the factorized and expanded version, and why? So just getting a conversation going about, in this case, cubics, but you could also do it with quartics if you wanted to. And then introducing the aim of today, which would be to factorize beyond quadratics. So we're assuming that they can already factorize quadratics. And so how is it harder to go beyond power 2? And then this is more for you than the students, but looking at the specification for Edexcel here, bold, we've got AS. We're talking about polynomials, factorization, and simple algebraic division, and use of factor theorem. Note that the remainder theorem isn't mentioned. And in the guidance, only division by linear terms here in the form ax plus b or ax minus b. This is factor theorem. Students may be required to factorize cubic expressions, so they do need to be able to factorize cubic expressions. One way you might have been teaching them how to do this is through long division. I'm going to suggest that we just do factorizing and skip the long division completely. And then in the year 2 topic, specification, we have got simplifying with algebraic division by linear expressions only. So there might be some division, or this could just be feeding into factorizing and cancelling. So I think it's a little bit vague about when actual polynomial division will be required, but I'm going to show you some questions and give you some context. Please note that this is actually a year 1 question. You can see in the bottom where I'm getting these from. So looking at a question like this with your students and introducing them to or reminding them about the factor theorem. So we've got the factor theorem. You can kind of read it both ways, can't you? So if x minus a is a factor of f of x, then f of a will equal 0. And then if f of a equals 0, then x minus a would be a factor of f of x. And so in this case, we are going from right to left. Prove x minus a is a factor. So we'd be looking at f of 4. They've got to sub it in properly. This many lines of working out would be acceptable, but they could do one more to be on the safe side for the 2 marks. And they have to have a conclusion. So nice gentle factor theorem question to get us going. And now extending this same question, but we're going to look at part B. Hence, using algebra, show the equation f of x equals 0 has only 2 distinct roots. And so I think the first thing most students might be tempted to do is go straight to their calculator solving polynomials. But in the text of the question, and in this case as well in the mark scheme, it does talk about calculator usage. And in the mark scheme here, it said that note that this question asks the candidate to use algebra, so you cannot accept any attempt to use their calculators to produce the answers. So going back to the starter from the beginning of the question, we know a factor of this already. And the factor is x minus 4. We actually know a root as well. So again, referring back to the starter when they were sketching it, a root of this will be 4. The way I teach this is get them to write out the polynomial on the left-hand side, and then all we're going to do is factorise on the right-hand side. I saw it written down, I think in the mark scheme, that they call this factorising by inspection. I really like that description for this. So what we're going to do is try and figure out what needs to go in this bracket to give the left-hand side. So whatever I put in, it's going to get expanded with this x, and I wanted 2x cubed, so a 2x squared would work nicely there. But by putting the 2x squared there, I've actually created this. When I come to expand, I've created a minus 8x squared, and we want minus 13x squared. I'm going to minus 5. If I just leave an x there, when I come to expand here, that will generate the minus 5x squared for me. However, it's also going to generate a 20x, and I want plus 8x. So I'm going to need to get rid of, or minus 12, and I'm just going to leave it as a 12 because it will become a 12x. When I get down to a constant, I close the bracket. And now here is the neat bit, because now I can see if I've done this correctly by looking at the last term. The last thing I need on the left-hand side is a 48. And if you look on the right-hand side, I've got minus 4 times minus 12, which is the only way of generating a constant. In this case, it will give me the 48. And so then two distinct roots. Interesting. Now they can be a bit, they can go onto their calculators and use it for this last step if they find it is helpful. We're trying to get 12, and I need a 5 in the middle. It's a bit of a tricky one because we've got the asymmetry between the two brackets of the 2x in one and an x in the other. If I put a 4 there, that gives me 8. I put a 3 there, that gives me 12. And I want minus 8 plus 3. And there was a kind of a hint that I was going to get x minus 4 in a bracket, so they were helping me there because it has only 2 distinct roots. Therefore, roots are 2 are distinct because we've got the 4 appearing twice, so we've got a double root, which again would help inform our sketch. Nice. Practice question. Very similar in style. You can let them do this one. Factor theorem, again in part A, so subbing in g of -2, making sure that they've got their conclusion. And then in B, it's a hence question. They've actually given you more help here because they're showing in the form that they've taken out the x plus 2. So again, I'd write out the polynomial on the left, take out the x plus 2 on the right, and then get your polynomial in the bracket, which we can factorise. And it looks like it's going to factorise into the same bracket twice, so another double root. This was a year 1 question. Some things to remind your students or some tips for them is to write it out as I've been doing. Polynomial on the left, take out a bracket on the right, work in decreasing powers. So as you're factorising the polynomials, look at the cubes and then look at the squares and then look at the x, and then we finish with the constant. And then we close the bracket after the constant so they know that that's when it's ended. And expand to check your answer, or just check the last term. You'll know if it's correct. More practice opportunities. Calculate f of 2 and write f of x as a product of 2 algebraic factors. This is a year 2 question, but you can see there's no real extension here from year 1. Getting your students to think about why is this useful? Why is this more useful than long division? It was really quick, and there's no new skills. It's just factorising, which is something they have to be able to do anyway. And when do we use this? It's when we're looking for either solutions to polynomials, or I suppose we should also say factorising polynomials. So I have found what a true year 2 question would look like. Super recent, actually. Last year's 24, paper 2, question 15, right towards the end. It is at part C, this 5 marker. I'll just set the give you an idea of what's already happened. So we've got this curve which we've differentiated, and there's a point on the curve, and then we're talking about the normal to the curve at the point. Prove that the normal does not meet C again. So we've already found once where they are meeting, and that's at 1. And so we know that this will be a factor. I'll just start this one off so you can see what I mean. So let's take, let's assume they are going to meet again. I am equating them, simultaneous equations, substitution. I'm going to take my time. Let me just add a new page. you can actually see me doing a full run through of this paper in one of my other videos, speedrun video. I'm going to move this all to the right because I like my first term to be positive. So we've got 6x squared, so 3x squared minus 6x squared. And then I've got minus 12x plus 6x. And then I've got minus 8, minus 8. And so this is the equation for where the two things intersect, and we already know one solution. Write out the polynomial, take out the factor. We want an x cubed, so that will be an x squared, and I've generated a minus x squared, and we want a minus 3x squared, so I need to minus 2x squareds, and then I want an 18x, and I've just generated a plus 2x, so I need to plus 16. And I like this because the constants, I want a minus 16, and I've got 16 times minus 1, which is minus 16, so that's good. Now we want to prove they don't meet again. So that means this discriminant, b squared minus 4 times a times c, hopefully, well, I can see, but hopefully will be negative minus 60. So that's got no real roots. Therefore, they do not meet again. To end with, I'm just going to show you a snippet from the examiner's report on this, which again, you are more than welcome to show your students. Having obtained a cubic, many candidates made little creditworthy further progress, and most did not link it to the earlier part of the question, so did not attempt to take out the factor. So this is where you can really emphasize to your students, if they see a cubic, they ideally need to be looking for a factor. This was perhaps understandable when the cubic was incorrect. So yes, if the cubic is incorrect, you won't be able to fully factorize it. The final 2 marks were only accessible to those who were very secure in their algebraic accuracy and knowledge, as these marks were contingent on both a correct cubic and a correct quadratic factor. So yes, super useful, and highly recommend teaching this technique to your students. It might take them a few tries to get used to, but I find that getting them to expand it at the end to check their answer is a really good way of reminding them of how the method works. If there's another topic you'd like me to go through, please leave a comment below. Thanks, bye.